Hi, welcome back. For this video, I'm going to talk about von Neumann. So you might want to say Neumann or Neumann, but I'll just use Neumann because that's what he is really called, von Neumann. Okay, so when I talk about von Neumann, normally this is the introductory part for the computer architecture uh, course. Okay, so later on I'll also show you a video, a pre-downloaded YouTube video about von Neumann architecture. But first, let me have this short lecture. Then we'll go to the video, and then I'll give some commentary. Okay, so the von Neumann architecture. Von Neumann architecture is the conceptual model of most general purpose machines. So von Neumann has four major components. You have the CPU, which is composed of the control unit, ALU unit, and registers. You also have the memory, which is the RAM and the ROM. You have the I/O, or input output, and last but not the least are the buses. So if you're going to search von Neumann machine, and then you want to see what it looks like, it's not really a machine, but it's a concept. So you get this one. This is normally what you'll find. This is what you'll see. Okay, continue. So for the different components, so the CPU is one of the components. It's composed of the ALU, the control unit, and the registers. And the CPU is considered to be the heart of the computer system. So the ALU does the arithmetic and logic operations. So all the addition, subtraction, multiplications, and of course the logical operation, and or not, and shift right, shift left. All these things are done by your ALU. So if you have the CPU as the heart of your computer system, ALU is considered to be the heart of the CPU. Kasi nga, siya yung gumagawa lahat ng mga processes. Then, you have the registers. These are small high-speed memory systems inside the CPU. Nowadays, CPU have also caches. So, hindi lang registers, meron ng caches. The registers save data that are to be immediately processed by the CPU. They can also contain control information. These are instructions that would tell the CPU what to do. On the other hand, caches are used to save data that need to be readily available to the CPU. These data are relatively more significant in size compared to what the register can accommodate. Kasi a register can only accommodate around 32 bits. Well, there are 16 bits, probably 128, but it's a stretch. Normally, you only have like 16 bits, 32 bits, 64 bits. Those are what your register can save. So one register, maliit lang. But for your caches, you have 512 MB. Then probably you also have like 256. These are much bigger than your registers. Then the third component inside the CPU is the control unit, which acts like a traffic controller. I call it traffic controller, traffic man inside the CPU. It makes sure it makes sure that there is a semblance of order when a CPU is processing data. So which data should be allowed to come, which will use the buses, and what mode of transfer, so and other things. So these are the three components within the CPU. Okay, so another component for the von Neumann machine is the memory. So we already said the memory, whenever memory is mentioned, pertains to your RAM and ROM. So there are many kinds of memory systems. So you have the register and the cache. These two memory systems are within the CPU. So you also have hard disk, USB drives, laser disc. These are also memory systems. But most often, when memory is being mentioned in relation to computer systems, it pertains to the RAM and ROM. So in von Neumann architecture, there is no distinction between RAM and ROM. They are simply referred to as memory. So memory is RAM and ROM. RAM is temporary storage for data. Data could be part of a program, the whole source code of a program, a database, user data, or any information needed for executing a computer program or running a process. Then ROM contains the startup instructions needed to boot a computer system. In modern computer system, without ROM, a computer will not start up. However, it is possible to design a computer system with the startup instructions saved in the secondary storage system, which is the hard disk. Kaya lang, if you do that, your system, the system will boot very, very slow. Masyadong mabagal. That's why they have to be saved somewhere. They have to be saved in a special memory, which is the ROM. Okay. Still under different components of von Neumann architectures, you have the I/O. I/O are devices that allow users to communicate with the computer system. The secondary memory is logically considered as a memory system because they store data, the hard disk. But architecturally, they are considered as I/O because of how they are connected to the computer. So, yan, this is one of the trivia there. So, pag sinabing hard disk, is it a memory or is it an I/O? So, you might ask, it's an I/O, it's a memory. So, both of you are right. But you have to put it in context. If you say it's logically, it's a memory because it can store data. But architecturally, it's an I/O because how it is connected to the whole system. Okay, then you have the last but not the least, you have the buses. So these are communication channels. So communication lines that pass information to and from the CPU. There are three types of buses. You have the address bus, you have data bus, and the control bus. So information that are sent to and received from the CPU are carefully assigned to their respective buses. Data cannot be sent through a control bus or address bus. Address can only be sent through the address bus, etc. So we'll also learn more about this later on. Then if you put them all together, a computing device is a complex machine that relies on its different components to function correctly. Fortunately, for a user, we are also users. For a user, these abstractions are invisible to him. So whatever is happening inside are invisible to the user. But for us, these are the things that we try to understand and study as computer engineers, because we are not ordinary users, but we are like computer engineer. All he sees are the displays in the monitor and some LED lights flickering in the CPU and other I/O devices. Most often, he does not know that there are many things going on his computer or his mobile device. Like now, as you watch, or probably will read the lecture, because I'll also upload a PDF file that you will read about this one. Okay, so CPU. Lastly, CPU is being referred for ordinary users. They always say that the CPU, the box, actually this is just where you put all the other components. That's not the CPU. The CPU is just a small part of that box. I'm sure most, if not all of you, have already seen the real CPU. So anyway, for recommended reading or some viewing, these are the four links that you might want to follow. Okay, so thank you. I'll end it here, but let's watch one of the videos that I've downloaded. I've downloaded it pre-downloaded because if I'm going to play it here, baka hindi kayanin ng aking internet connections. It's called von Neumann. So,
hello everyone, welcome to a series of lectures on computer architecture.
Okay, so once in a while I'm going to pause and give some commentaries, but actually there's not much a need for commentary because I've already given the preliminary lecture, but still I'll give some quick commentaries. Okay, start here. Wait, I'm looking for the start somewhere, but I will skip the some parts there.
Time. Have a look at this picture over here. This is a very important early computer system. This is the Colossus. It holds the distinction of being the world's first programmable electronic digital computer. And this was built in 1943 at Bletchley Park in the UK to help with the job of breaking German codes in World War II. So even though it's of great historical significance for computing, the actual Colossus and the work it did was a national secret for a long time. When I was at school and going through the start of university, the American ENIAC system was usually credited with being the first programmable electronic digital computer. But in fact, the Colossus came out a couple of years earlier, but was then kept as a national secret. Of course, if any of you have seen the film Imitation Game about Alan Turing, you know a little bit about Bletchley Park, the work that was done there, and why it was kept top secret. So even though the Colossus was a great breakthrough in computer technology, it did have a problem. And this was that although data could be stored in the memory of the Colossus, it couldn't store programs in memory. That meant if you wanted to change the program, you had to get into the guts of the machine and rebuild the cables and the switches needed to make your new program. This was very time-consuming for the Colossus and early computer systems. So, for example, the American ENIAC system, which came out a short time later, I believe it took about 3 weeks to rebuild all the patches and cables and switches required to change the program.
Okay, I'll pause it there. So that's the main reason why von Neumann came up with the von Neumann machine architecture, because of this problem. So early computers cannot save programs in the memory. They can only save data. So imagine if you want to run something, or you want your computer to run something else, so it has to be it's parang you have to remove some wires, and then it will take you weeks to rewire it somehow, so that it could do something else or reprogram it. And then later on, actually what they have is like you have like a parang card where your program is, and you feed it in the computer. But the two examples here, which is the Colossus and the ENIAC, they have to be rewired when you run a program. Otherwise, it will just keep on doing the same thing. No problem with the Colossus, because the Colossus is just, it's a special purpose machine. That's all it does, is just to break some codes, German codes. But for ENIAC is supposed to do something else, some computations. So that's the main reasons why von Neumann come up with that architecture. And then he also mentioned about the ENIAC and Colossus, and there are still some books that will tell you that it's ENIAC is the first programmable electronic digital computer. But he also explained that since during that time, Colossus is kept as top secret. Of course, you don't want German to know that you have this machine that uh, could decode their whatever communication that are being their communication system, yeah, decode. So kept top secret. That's why some of the books will still tell you that the ENIAC is the first programmable electronic digital computer. Okay, so we will continue, and then skip a bit lang sa 30.
One of these great people who was involved in the early days of computer technology was John von Neumann. John von Neumann really was one of the great intellects of the 20th century. He was a very gifted American-Hungarian mathematician who made great advances in set theory, game theory, and was also involved in the Manhattan Project, which was the project to build the first atomic bomb. However, in the context of this lesson, we really want to look at his contribution to computer science. And this is what is now credited as the von Neumann architecture. In 1945, he described a computer architecture in which both the data and the program were stored in the computer's memory. Now, by having the program stored in memory, it made it a lot easier to change things, because the data and the program are in binary, they're stored in the memory, and you can change the data and the program whenever you like. And this is still the fundamental design concept behind all modern computer systems.
Okay, so again, I'll pause it here. So there, because of the von Neumann architecture, so after that, computer scientists realized that, oh yeah, von Neumann is right. Correct si von Neumann. So they started adapting his architecture, and they were able to see na talagang it's better to have this kind of architecture than sticking to the old architecture, wherein you cannot save the program in your memory. So after that, they live happily ever after, just like a fairy tale. Actually, tayo yung naging we are the beneficiary. Tayo talagang pinakamalaking beneficiary of this von Neumann. Not actually everybody who is living now. We are the biggest beneficiary. Okay, so again, I'll skip a bit. I'll go somewhere 5 something. Made some list. There.
Classic diagram. If you do a search for von Neumann architecture on Google Images, you will get lots of very similar diagrams. So again, at the top here, we've got the key point that the memory holds both the data and the program. We also have things like the control unit, the arithmetic logic unit, we've got input, outputs, we've got accumulators, we've got lots of other features. One point to make is that when we talk about computer architectures, we're not talking about a specific design for a specific computer system. We're talking about something that is more abstract and that can be applied to lots of different computers, as the von Neumann architecture was. So let's go through some of these key points. So we can see here we have a control unit. The control unit is responsible for decoding the instructions from the program and controlling how data moves around the computer system. This is why we call it a control unit. We have the arithmetic logic unit, or ALU, and this basically does all the math and logical functions. It carries out all the calculations. It does all the addition and subtraction, all the greater than, less than, all really the key processing that we think of when we think of a computer system. We also need to transfer data around our computer system, and we do this using buses. And buses are simply the wires that carry the data around the computer. In this diagram, they're donated by my mind has gone completely blank. That's the trouble with doing a live video. They're denoted by the arrows connecting the different parts together. So if you look at a motherboard very closely, you'll see the little wires running along the motherboard, and these are the buses that carry the data around different systems.
Okay, so I'll pause it here. So if you will continue watching this lecture, it will continually talk about the different components of the von Neumann architecture. So if you're still interested, you can watch it. Besides, I've included the link for the video, the YouTube video in my lecture. So we'll go to the last part. This is 12:14. This is the sort of parang conclusion part.
Okay, in summary, the von Neumann architecture includes program and data loaded into memory. This is what made it better than older systems like the Colossus. Sometimes the von Neumann architecture is called the stored program computer because the program is stored in memory. And this makes it a lot easier to change the program. It needs a control unit, an arithmetic logic unit, and registers. And registers are memory locations with a special purpose that are used temporarily while the computer is running. Okay, I hope that wasn't too painful, and I hope you stayed awake. And I will look forward to seeing you all in class, ladies and gentlemen.
Okay, so thank you for staying awake. So we'll have more lectures similar to this one. So probably I'm going to use this kind of formula whenever I'm going to upload the visual lecture. So I'll have a short lecture first, and then I'll have some video that you're going to watch somehow parang to support what I have just presented. Then after that, while the video is being played, I'll probably post it. Once it posts, do some posts and give some comments, and then basically that will be more or less the formula for the succeeding lectures. So hope to see you again. I hope that you're going to watch again the succeeding